Oh, that window? Is that really it? Yeah, it is. Okay. You don't know what I'm babbling about, and that's probably for the best. Here we are, the solar system. Okay, so this time we've got Earth and Moon. Okay, there we are on the surface. Yeah, and there's the moon, that little dark spot. The sun is blacked out so that we can see everything else in the sky. Yeah, and they're pretty much the same size in the sky, yeah. Little tiny dot, as it's rendered here in Universal Sandbox. It's actually not that much bigger when you go outside and see it. The thing is, the moon only takes up half a degree of the span of the sky. You can cover it up with your thumbnail, pretty much. But when you buy a science fiction book, and it shows, oh, look, you're in an alien or fantasy world, here's these 3 or 4 great, huge moons in the sky. Yeah, it doesn't work like that. And today we're going to show you exactly why it doesn't work like that, because we're going to put 5 moons in orbit of Earth. Not 5 moons, but 5 moons that are spaced out in orbits and size so that they look the exact same size the moon looks. In order for multiple moons to stay in orbit around an object, they have to have a resonance. They have to have a certain number of orbits for each one so that the gravitational pulls they have on each other don't get out of balance, and thus one moon or another throw each other out of orbit. This can happen. Another thing that can happen is the 2 moons can gradually spiral in and collide with each other because of gravitational attraction. But if, say, for example, a moon is orbiting 5 times for every 2 times the next one out orbits, that is usually going to be a stable resonance, because they're going to be passing each other. They're going to have the closest approaches on opposite sides of the primary body, i.e. Earth. And that should keep things stable. If I get close enough to that resonance, then the gravitational effects will naturally zero them in on the resonance, at least in the short term. Going for the 5-to-2 ratio, I decided I was going to begin by deleting the moon. Say goodbye to the moon. Moon. Okay. No, what we want is to put another object in orbit around the Earth at a distance where it will orbit the Earth in exactly 2 days. I did the math using an online website. You can find all sorts of instant calculation websites these days, and there is one that calculates orbits around Earth. And if you want a period of 2 days, the object needs to be orbiting at roughly 60,800 kilometers above the surface. To give you an idea, it's roughly speaking 20,000 kilometers to orbit in 1 day, i.e. geosynchronous orbit. Now, at that height, in order to look like the same size in the sky as the moon is, you're going to need the diameter of the object to be 531 kilometers. Fortunately, there are objects in the solar system that kind of approach this. In particular, the asteroid Vesta, which is the 4th largest object in the asteroid belt, has a diameter of 525 kilometers. So we'll be using that for our first moon. There we go. Anyway, there's Vesta, and if I hit play, there it goes. Tickety-boo. No problems to speak of, except overview. Vesta is on the edge of the zone where water ice becomes stable under the intensity of sunlight. You go further out than the asteroid belt, you get the gas giants and the ice giants, and eventually the Kuiper belt with all its icy objects. Inside the asteroid belt, the solar wind and other effects make ice sublimate. It melts and blows away in the solar wind. And so pretty much all you've got are rocky planets like Mercury, Venus, Mars, and of course Earth. Earth only has water because it has an atmosphere, which helps protect it and keep it in. And of course, it also has a magnetic field. The magnetic field blocks the solar wind from whipping away the atmosphere and thus whipping away the water. Average temperature 7.79 degrees Celsius. But Vesta is rocky enough that that's not an issue, at least not right now. So, zoom out. And it's time to put down our next object. Remember, we're going for a 5-2 ratio, which means since this orbits 2 days, we want the next one out to orbit every 5 days. That means it has to orbit an altitude of 117,200 kilometers. And in order to look the same as the moon from the surface of the Earth, it needs to be 1,023 kilometers across. And for that, we want a moon of Saturn, specifically the moon Tethys. Now the thing here is, Tethys is almost entirely water ice. So I fully expect this to act like a comet once we start time going again. And gradually that will mean that the surface will sublimate and it will start losing mass. How quickly, I don't know and couldn't guess, but 17.1, that's good enough. Alright, so there's Tethys in orbit of Earth. And let's go ahead and go over here and set the thing to 7 degrees Celsius, which is roughly speaking the same temperature as Earth is on average at this orbit. So now when I hit play, we should get something like a cometary trail coming off of it. Except, interestingly enough, not. And time is going forward. Of course, this is average surface temperature, and there might be just tons and tons of latent heat not present. Latent cold, I guess you could say, that's dropping the surface temperature. But suffice to say that an all-ice moon would be a comet in Earth's orbit. For some reason, the game isn't simulating that, but we'll just move on. So, 2 days, 5 days. To get the same ratio, the next one out has to orbit once every 12.5 days. That puts it in an orbital altitude of 218,200 kilometers and a diameter of 1,904 kilometers. We kind of hit an empty spot in the relative sizes of objects here, but the closest thing we can get is the dwarf planet Pluto at 2,180 kilometers in diameter. 218.2, 218.4, that's going to have to do. Now, Pluto is made of methane ices, among many other ingredients, but methane is a huge proportion of its mass. So, I fully expect this to be very cometary. Surface temperature 7 degrees Celsius. Do you do the sublimating thing? Oh yeah. Earth has a farty moon. So far we've got 3 moons. And if we go to Earth's surface, okay, there's Tethys. We found Tethys. Okay, there's moon orbiting Pluto as opposed to original Pluto, way off there. And there's the suns. You'll notice they all look the same. The sun and the moon are about the same apparent diameter in the sky, so that's how we know we're doing this more or less properly. So, we've got 3. Pluto at 12.5 days. The next one out has to orbit at 32.5 days. which means we're now going outside the orbital average of the moon, which is roughly speaking I don't even need to go roughly speaking, 382,000 kilometers above the Earth on average. The moon's orbit is elliptical, so it's not always the same. It's about a midpoint between the two extremes. 32.5, diameter of 3,700 kilometers. Moon's diameter is 3,470, so this has to be marginally larger. And for this, we want Jupiter's moon of Io. Speaking of farty moons. Pluto brings the methane. Io brings the sulfur. Okay, so let's hit play. There's Vesta, Tethys, Pluto, and Io. All chilling out. Perfectly happy with one another. And still pretty well inside Earth's gravity well, but we're about to change that. Because here's where things start to break down. And we have to talk about a thing called a Hill sphere. The Hill sphere is the area of gravitational influence around a body. It's the area where, for example, the Earth or Jupiter or whatever, wherever a body has the dominant gravitational force in the area. If you're Vesta, Earth's gravity dominates you at the moment. But if you're Io, Earth is still kind of dominant, but you're far enough away from it that maybe the sun has a bit more to do with it, because the sun is a lot bigger than Earth, but it's a lot farther away. So we're about to put down another body that's even farther away from Earth, which means the Earth's gravity is going to be less, but it's going to be the same distance away from the sun, which means the sun's gravity is going to be a bit more dominant. And to make things even better, we've been sizing these out so that each one is apparently the same size in the sky as our moon. Io is already going outside the moon's orbit. This next one is going to go way outside the moon's orbit, which means this object is going to have to be that much bigger. If Io is orbiting twice at an altitude of 424,000 kilometers, in order to orbit 5 times for every twice Io orbits, the next object out has to be 794, nearly 800,000 kilometers above the Earth. And its diameter has to be 6,930 kilometers, or in other words, roughly twice as wide as our moon. So now we're talking actual planets. We're about to put Mars in orbit of Earth. Now, at this point, it's an open question whether or not Mars would even stay in orbit of Earth, because we are getting out close to the edge of Earth's Hill sphere. But we're going to give it a shot. Now, bear in mind, these are all perfectly circular orbits, which never happen in nature. Can get pretty close, but never perfectly circular. This is ideal conditions as far as maintaining an orbital resonance. All right. There's Mars, Io, and the other two inside. Let's roll time and see what happens. Okay, you already notice that the eccentricity of the orbits are kind of changing here. So far, it looks like Mars is sticking put. But its orbital eccentricity keeps climbing. And look at this already. Mars's orbit is shrinking. Or rather, no, it's captured Io. It's captured Io, and this is not going to end well. Okay, Io is going to auger in a moment, so let's stop this. Before we do this, let's take a quick look at Earth. I want to see what the temperatures are, because there's something I haven't really brought up yet, and that is tidal effects. The moon has a fairly significant effect on the Earth through its tides, not just sloshing water around in the oceans. It also affects the rocks, and right down to the core of the Earth. It churns up the insides of the Earth. The moon is also churned up a bit by the Earth. So, yeah, it's no longer as radical as it was when the Earth and the moon first formed. The moon used to be much, much closer to Earth. But there is still an effect, and the tidal forces on each body heat them up a bit, make them warmer than they otherwise would be. So right now what I'm looking at here is average temperature 7.27. So all these extra moons have added 1/10 of a degree Celsius to the average temperature of Earth. Not that much. The ones that we put close to Earth are pretty small, and the big ones are well out, so we don't have to worry about that so much. But meantime, we've got a show to watch. There comes Io. This is about an hour and a half every second, by the way. We're currently passing through the cometary trail of Pluto. Here we go. And now Earth is classified as a binary of Mars. That's interesting. And that's not going to last much longer either, because the collision with Io has slowed almost all of Mars's orbital trajectory. As a result, it's on a collision course with pretty much everything. Oh, look at the average temperature over 900 degrees Celsius after impact. Mars is cooking now. Oh, it's worse than I thought. The impact with Io didn't just slow it down. Mars is now technically in a retrograde orbit of Earth. And I don't think its periapsis is high enough to avoid getting pulled in. So here's where Mars cleans up the rest of our moons. This is what happens when you don't have stable orbital resonances. The reason this happened is that Mars was just too big. Its hill sphere was too large, and it ended up grabbing Io out of Earth's grasp, with the results you've already seen. Oh. And that was a very narrow miss. And this ought to be a lot higher, because that would be catastrophic, civilization-ending tidal effects, Mars swinging that close. Okay, Vesta's about to buy it. Except not. It was a near miss, and Vesta's got flung into a new orbit around Earth, apparently. But yeah, with Mars coming in that close every time, that's just not going to work out. So, and Mars has just flung Pluto out of Earth's orbit and into probably an escape trajectory, in all honesty. I mean, technically it still shows as being in orbit of Earth, but that's way outside Earth's hill sphere. I don't see that coming back. Alright, so another close approach by Mars. Oh, and that time I think Mars actually got disrupted. Yeah, Tethys is still there. Vesta is technically still there. But Mars passed so close to the Earth that it passed inside its Roche limit. The Roche limit is the point at which, if you get a certain body close to a planet, the tidal effects rip it apart. How close that is depends on what the moon is made of, and how big the moon actually is. Mars being really big means it has really big tidal forces if it gets closer to a bigger gravity well. And as a result, well, boom. Average temperature went from 600 degrees Celsius to over 2,000 degrees Celsius. And I can't imagine that did Earth any favors either. And yet it's not simulating. It's 7.38 degrees Celsius. Nice and comfy. Despite everything. Meanwhile, there's Pluto going way out there saying, you do you, man. You do you. Tethys is now saying moon flying into Earth. The last pass caught Tethys at a bad time, and now it's doomed. And this is going to do Earth no favors either. And Earth went from 7.5 degrees Celsius to an average of 43.5 degrees Celsius. That is about 140 degrees Fahrenheit. Well, no, it's 110, 120 on average across the planet. Suffice to say, human civilization is donezo. And now Earth is down to 2 very elliptically orbiting moons, which probably aren't going to last that much longer. So, those 5 moons didn't work. Why? Mars was just too big. So the 5-to-2 ratio isn't going to work out. This time we're going to go for a 3-2 ratio, which is about as tight a ratio as you can get and still have a stable orbit, at least in theory. And this time we are going to begin again at an orbit 2 days out from the Earth. So, which means, yes, we're going to erase the moon again. And we're going to begin by adding Vesta back where it was. That's close enough. But now, instead of having 5 for 2, we only want 3 for 2. So the next one out is going to be at 81,500 kilometers. And the diameter for that to look the same as the moon in the sky would be 711. The closest is an asteroid called Ixion, which I think is actually a Kuiper Belt object. Not 100% sure. We're about to find out if it even exists in Universal Sandbox. Mass unknown, radius 337 kilometers. Okay. This doesn't seem quite right at all. I have no earthly idea what I'm doing here. But we're making this almost entirely water. Except we're going to give it a bit more methane. And already weird shit is happening to this. So this should be very cometary once we crank up time. Oh yeah. It's already evaporating. Moving on. 2-to-3 ratio means the next one out orbits every 4.5 days. And for that, the diameter needs to be 950-ish kilometers, which is almost exactly the same size as Pluto's largest moon. No, not Pluto's moon. Pluto's Charon, which we haven't got to quite yet. No, we're going for the largest asteroid in the asteroid belt, KRIS. There we go. Now, KRIS is mostly water, but not practically entirely water like we just made Ixion. Well, evidently, so far as Universe Sandbox is concerned, KRIS is rocky enough that it doesn't become a comet immediately. 4.5 days, 6.75 days is the next orbit out, 144,500. To look the same size as the moon in the sky, it would have to be 1,261 kilometers across, and that is Charon, the moon of Pluto. There we go. All right, so that's 1, 2, 3, 4. All good so far. So for magic number 5, 191,300 kilometers out for an orbital period of just over 10 days, diameter of just over 1,600 kilometers, that's kind of a gray zone. There's not really anything in the solar system that fits that. The closest that we've got is Uranus's moon, Titania, with a diameter of 1,576 kilometers. 1,300. Good enough. Titania is orbiting at slightly less than half the distance that the moon orbits from Earth. So if small bodies will make 5 moons stable around Earth, this is the deal. Okay, that's going to be 3 hours a second. That's good enough. Okay, we're going to center on Earth here, and we are really going to crank up the time warp here. The James Webb Space Telescope is not happy with any of this, as you might imagine, but Titania doesn't quite look perfectly stable. It's a little bit eccentric. But so far, they're all holding together fairly well. I don't want to take this any faster than this. This is 5 days per second as it is. And Vesta is pretty much a blur inside there. But, yeah, that is 1 year of 5 moons. Eccentricity 0.003. It's not 0, but it's kind of close. Ixion is slightly more eccentric, 007. KRIS orbital eccentricity 0.02. That's a lot more. Charon 0.01. 0.01. Okay. So what that means is these all started out with an eccentricity of 0. These were perfectly circular orbits to begin with. They're not circular anymore, but they are not far off. And basically, gravitational resonances will keep these moons more or less where they're at for probably a very long time. That's Ixion, and that's Ixion's cometary trail. So it doesn't exactly look like the moon, but anyway, there's Ixion. That's the sun. And so, yeah, there you go. Yeah, it would help if Universe Sandbox actually made the moon and stuff look what you'd expect them to look like, but it doesn't. So, yeah, we've accomplished our goal, but it doesn't look all that impressive. And more to the point, our moon isn't in it. So, I made up a third set of calculations, with the outermost being our moon. Now, if my math is correct, and this is already looking wrong, by the way, but if my math is correct, this also is a stable arrangement. The only question is, Pluto, although nowhere near as massive as Mars, is still kind of massive to be this close to the moon. And the moon is pretty hefty. The moon is 1% the mass of Earth, which sounds like it's really dinky, but Earth is gigantic in terms of solar system objects. If you count the sun, it's the 6th biggest object in the solar system. So, okay, this is 3 hours a second. Passing through January 12th. So far, no obvious issues. But bear in mind, the moon takes basically a month to orbit. That's why we have the word month. And, yeah, even though I haven't preemptively warmed up Pluto, it is still farting. So far, these are all appearing to stay in their own lanes. But is that going to remain the case when I kick this into high gear? Okay, that is a bit fast. Oh. Okay, shenanigans just happened. Pluto and the moon got too close, and they very nearly had a collision. And now Pluto is well out of its original orbit, and it's coming inbound to sweep up these smaller moons, maybe. And it only took about 2 months, by the way, for the moon and Pluto to screw each other up. Okay, here's the moon. Remember, we had the moon and Pluto definitely set at an eccentricity of 0, and I'm assuming that the same was the case for the other 3 that I auto-placed. Orbital eccentricity of the moon now is 0.197, pretty much 0.2. So that's pretty well increased. Pluto's is going to be through the roof because look how elliptical that is. Earth is over here, 0.7. So yeah, pretty damn big. So although its orbit is in here, and it will eventually kick all 3 of these into different orbits or just collide with them. And that's assuming it doesn't make a collision with the moon at some point, because the moon will have another close encounter with Pluto eventually. Pluto's current orbit here near its apogee, the highest point it is above the Earth, its altitude in kilometers is 300. It's pretty much where the moon was. And then it goes down here, which this would be inside a geostationary orbit. We wouldn't have a GPS system anymore. Pluto would have cleaned them all out by this point. Anyway, you got the point. That's not stable either. There's one thing that we could still do. The issue with this is that Pluto and the moon were too massive and too close together. The moon is just a chunky boy. And the moon being that big is why we don't have any other moons. That and the fact that we're so close to the sun. The moon's gravity kicks out anything else in Earth's vicinity that could have formed another moon. And so long as that's there, multiple moons are unlikely. And 5 moons at one time are just out of the question. But there is one last thing that we can do just for shits and giggles. And I think I might actually have this one saved. Okay, this is more or less the same setup that we had before. The original set with Mars on the outside, except they are much, much, much closer. Yeah, Vesta is breaking up. It's too close to Earth in this setting, so it just can't cope. Now this looks very pretty, doesn't it? The thing is, there's consequences. And I don't think they're far off. And you'll see that Mars and Io are already kicked up way higher than they were. Either that or the other three have been brought down way lower. So yeah, this is not stable in any way, shape, or form, and we're probably going to be seeing some collisions in the near future. There we go. And I hit 7 and immediately jumps to 11.7. Oh, and okay. We just lost a moon while I wasn't looking there. Tethys just went bye-bye. Pluto's kind of bruised. Average temperature, 311 degrees Celsius. That is some cooked methane. Okay, this has been going on for about 3 weeks now in game time, I think. I haven't been paying close attention. And there goes Io. Blammo! And Earth is getting hit too by a lot of these shots, so average temperature 73 degrees Celsius. Humanity is cooked. Ooh. A big bomb came down and took out West Africa. Oh, I spoke too soon. There went Vesta. Looks like Vesta got flung into Earth. Although Pluto caught some of it too. 258 degrees Celsius. And Earth, oh my goodness. 2,249 degrees Celsius on the surface. We've been atomized. When you see multiple big shiny moons on the cover of some fantasy or sci-fi novel, well, fantasy is exactly what it is. Because if you saw moons that big in the sky, this would be the result. Thanks for watching, everybody. See you next time.